So, how many of you play a sport? Who plays sports in this room? Hands up. Let the record show that nearly everybody in the room is raising their hands. Okay, good. Does anybody play soccer?
Well, I used to when I was like,
Okay, good. What happens when one person comes out and another person comes in? They sub somebody, right? Okay, so that's with all sports. I just happened to pick soccer because I was watching a soccer game yesterday. All right, so substitution, you exchange one equal player for another equal player, supposedly, right? The guard for guard, whatever, forward for forward, okay? Well, let's not get into the technicality. Let's just stick to the general idea, right? Substitution in mathematics works the same way. You can replace one equal value for another equal value. So that's the idea behind substitution here. So let's do an example together. If I say y is equal to 3x, and I have x plus y is equal to negative 32. So check this out. What I have is a system of linear equations, and I'm interested in solving it. We could graph it and see where they intersect, or we could use substitution. In this example, it's a better idea to use substitution. Why?
Because they already tell us the value of y, so you can just plug it right in.
They're not in the same form. That's true. And like Jay is saying, they're telling us that every y value is equivalent to 3x values. That's what that says. Every y value is equivalent to 3x values. So look, I can replace this y right here with 3x. So I'm taking a value from one equation and I am substituting it into the other equation. To create a new equation, that would be this, x plus, now instead of y, I would substitute y with a 3x. 3x, and I get negative 32. This situation is much more inviting for us simply because now I have one equation with only one variable in it. The variable is x. If I have one equation with one variable, well, I can solve for that variable. Obviously, 4x is worth negative 32. Dividing by 4. Hey, how much is 32 divided by 4? So that would be a value of negative 8. Once I know that x is worth negative 8, I can take that information and substitute it right back into the top equation to tell me that y has to be worth 3 times a value of negative 8 to make that relationship true. Therefore, y is worth, hey, how much is 3 times negative 8, everybody? Negative 24. So my solution would be negative 8 comma negative 24. Okay, ladies and gentlemen, would this be an inconsistent or a consistent system? This is consistent. I kind of said the intonation weird, but it's consistent. Okay, now, if it's consistent, is it dependent or independent? Independent, consistent system. Very nicely. Okay, here we go. We're going to do another substitution. Now, this one's a little bit more challenging only because we're not given a direct substitution. We actually have to do some work. Now, of the two equations, the top one or the bottom one, which one has a variable that is by itself? The bottom one, right? I'm thinking that right here, right? If I could get that thing solved for y, I'd be good to go. So I'm going to go ahead. My preliminary move is to solve this equation for y. So an equivalent statement is to say this. Y is worth 2x minus 3. So every y is worth double the amount of x, take away 3. Everyone see that first move? Now, if every y is worth a 2x minus 3, I'm going to take this information and I'm going to substitute it in for the y value in the other equation. Okay? Right, because if I substitute it back again, right, then I'm not sure what I got there. Okay? So, here we go. I would get this. 3y. But remember, y is worth what? 2x minus 3 plus 4x's has to be worth 14. Okay? Sorry, I'm going to switch up here. There we go. Okay, now I'm going to distribute. So that's going to be 6x minus 9 plus 4x's has to be worth 14. Any like terms on the left-hand side of the equation, ladies and gentlemen? 6 and 4 make 10. So 10x's, take away 9, has to be 14. I'm going to add 9 to both sides and get that 10x is worth how much? 23. Good. If x is worth 23, I'm going to divide both sides by 10. So x is going to be worth what? 2.3. Is that okay? Can x be worth 2.3? Is that okay? Yeah, why not? That's no big deal. Okay, now that I know that information, I plug it right back to any x that you want. I'm noticing that that one right there looks pretty straightforward to use. So I'm going to get y is equal to 2 times 2.3, take away 3. Well, that's going to be, what, 4.6 minus 3? So what would that be? Okay. See what you guys do. Okay, great. How can we check this? How can we actually check this? Do we have any skills? Do we have any calculator skills that would actually see if we could check this? Well, let's use our calculators to do it. Let's add a little practice in here. Okay, ready? Here we go. Let's hear it. I have to solve both of those for y right away. So go ahead. The first one, if I'm going to solve that for y, ooh, I should do that right now before we actually start, huh? Okay, if I'm in a different color here, I'll use green. If I want to solve this equation for y, what would it be? 3y is worth negative 4x plus 14. So y is negative 4/3 x plus 14 over 3. Yikes. Okay, good thing we solved that thing first. Okay, here we go. Let's plug it in. Here we go. Here's how you plug this in. I'm going to use parentheses and say negative 4/3 x. So notice what I did there, everybody. I use negative 4/3 as a fraction, and I use parentheses. Now, make sure you don't use the minus sign. Your calculator has a minus button, which is over here on the right-hand side in gray, and it has a negative button, which is below the 3. That's the one you want to use. So negative 4/3 x, and then plus. I just use divide, just the divide sign. Yes, put the fraction in parentheses. Put the fraction in parentheses, okay? And that would be 14 divided by 3. So, yes, it will. Because your calculator will think it's doing something else, okay? So use parentheses whenever you're using fractions. Keep it together. All right, my next equation is pretty simple. It's just 2x minus 3. 2x minus 3. Notice I used the minus sign because it says 2x minus 3. Okay, everyone good to this point? Good. We're all going to hit zoom 6 now. There's my first line. And my second line should be in red. And there it is, because the calculator's thinking, right? Okay, is this a consistent or an inconsistent system? It's a consistent dependent system. Perfect. Now let's find the intersection. So, what did I just say? Oh yeah, consistent, independent. Yes, that's right. Second calculator. What option do we want? 5. Very good. Am I on the first line? Am I on the second line? Okay. Do I want to guess? No, let's just actually hit the button. Hey, 2.3, 1.6. Hey, that's what we got. 2.3 and 1.6. Awesome. Math is red. Okay, we have to talk about this type of an example. I call this a crazy example. All right. I'm going to use substitution because in my first equation, x is already solved for me. So I know that every x is worth negative 2y plus 4. So I'm going to go ahead and plug it right there. So I get 3.5 multiplied by negative 2y plus 4 plus 7y is worth 14. Okay, help me out. All right, what is 3.5 times negative 2? That would just be negative 7y, right? Okay, what's 3.5 times 4? 14. Whew, 14. Okay, plus 7y is equal to 14. Any variables that are like terms on the left-hand side of the equation? Yeah, negative 7y plus 7y cancels that. So I get this statement. I get 14 is equal to 14. What does that mean? That is a dependent system. That's an infinite many solutions, okay? That's something crazy. So if you get a true statement, you can infer that there are infinitely many solutions. Now, we're going to do another example, same box right below it of this. Y equals 3x minus 11, and y equals negative 3x minus 13. Oh, excuse me. excuse me, I wrote that wrong. Y minus 3x, excuse me, equals negative 13. Okay, wrote that wrong. So let's focus on this one for a second. How much is every y worth? It's worth a 3x minus 11. So if I'm in the mindset of substitution, I'm going to go ahead and substitute it right there. So I'm going to get this, 3x minus 11 minus 3x, thank you, minus 3x is worth negative 13. Anything cancel out on the left-hand side. So I get negative 11 is worth negative 13. Now, here's why I want to do this side by side. Compare those two. Compare this statement here to this statement here, because they mean something different. Compare those two statements. Anybody got it?
Yeah.
I know you think you got it. I'll hear from somebody else. Will, what do you got?
There's no solution.
Yeah. Is it a true statement or a false statement? Pulavi, what do you think?
It's a false.
It's a false statement. So if I'm getting a false statement through the algebra that I'm doing, that would suggest to me that my system has no solution, or it's inconsistent. Okay? So this would be no solution. Oh, let's use a different pen here. All right. No solution. Inconsistent. All right, the last part of our day is talking about the elimination method for solving a system of linear equations. So we can already graph it. We can graph it in our calculator. We can tell whether it's consistent or inconsistent and dependent and all that kind of stuff. We can also we can solve it by substitution. The last way, which is usually everybody's favorite, is solving a system by elimination. All right, so the idea behind solving something by elimination is to do just that, to eliminate a variable. So this question is set up very nicely because I want to draw your attention to right there, those two highlighted parts there. Do you notice that one of those is positive 5y and the other one is the opposite, negative 5y? That's a good thing. Here's why that's a good thing. Because if I consider this a statement that I just want to add vertically, look what I'd get. How much is 17 take away 9? How much is that worth? 8. Okay, so 8 on the other side. How much is 5y take away a negative 5y? Well, shoot, man, that's 0, isn't it? How much is 2x plus 6x? 8x. Well, oh my gosh, check it out. If I just divide by 8 on both sides, I can see that x is worth 1. And that was pretty quick. Pretty quick. So if x is worth 1, am I done with the problem? No, because I need to figure out what y is worth. So I can take this information and substitute it back, and we'll go ahead and use purple. So we know 2 times 1 plus 5y is worth 17. 2 times 1 is the number 2, plus 5y is worth 17. So therefore 5y is worth, if I take 2 away, what would I get? I'd get 15. I could divide both sides by 5, and I would see that y is now worth 3. So the solution to this particular equation would be this, 1, 3. What type of a system is that? How do we classify that? That would be consistent, independent system. Very good. Okay, this will be our last example. This is a challenging example to use elimination. Why? Why is this a challenging example to use elimination? Isabel, what do you think?
Because they're both positive.
Everything is positive, and the coefficients, meaning the numbers that are right in front of the variables, they're not the same anywhere. So we have to do something first. Palali, what do you think we have to do?
Is it like you have to find?
Yeah, we have to find a common multiple, okay? So first, you should pick a variable that you want to eliminate. It doesn't really matter at this point. Do you want to eliminate the x's, or do you want to eliminate the y's? You want to eliminate the y's. Okay, look. So dealing with the y's, I have 2y up top and 3y on the bottom. So 2 and 3. So here's what I'm going to do. I'm going to multiply the top equation by the number negative 3. I'm going to multiply the bottom equation by the number 2. Who sees why I did that? Who sees why? One person in the room sees why I did that? 2 people in the room, maybe? 3 people in the room? Alice, you see why I did that? Okay, Evan, can you explain why I did that?
Because you want to eliminate one of the variables.
Yeah, I want to eliminate, but how does doing that eliminate a variable? Go ahead, Brandon. What do you think, dude?
Multiplying 2 by -3 will equal -6, and multiplying 3 by 2
Yes.
6.
That and that and that and that together. When you multiply those together, they will create opposite numbers. They will create -6 and 6. And when I add them together, they will be eliminated. That's why we did what we did. Okay, so I'm going to write down a new system in purple here. So this is going to give me, how about -9x minus 6y is worth -3. Did I do that correctly? -3, a -6x, and then a -6y and a -9x. Okay, so far so good. Okay, now let's do the bottom one. 2 times -2 would be -4. 2 times a 3y would be positive 6y, and 2 times a 4x would be a positive 8x. Now I'm in a good position to add these up vertically, and noticing that the y's have been eliminated here. So -9x plus 8x, how much is that worth? That's worth -x. This and this cancel out. This is equal to -7. Therefore, x should probably just be regular 7. Am I done with the problem, though? No, why not? Solve it in for y, and we'll use pink. So here we go. 3x plus 2 times 7 has to be worth 1. So 3x plus 14 has to be worth 1. So 3x has to be worth, what would that be? -13. -13? Well, that didn't turn out to a nice integer, but that's okay. Did I do something wrong? Question, yes. I did do it wrong. Thank you. I plugged in the wrong spot. It's a good thing someone's paying attention around here. Lord knows it's not me. Shoot, man. Okay, we'll still use pink because it's fun. Let's put it in the right spot. How about this? How about 3 times 7 plus 2y is worth 1? Does that make more sense to us? Yes. Okay, good. How much is 3 sevens worth? 21. Thank you. 21 plus 2y is worth 1. Therefore, 2y's has to be 1 take away 21 is what? -20? -20, right? Divide by 2. Divide by 2. Now we're talking -10. Whew, that's a lot easier. Okay, so all said and done, the answer to my system would be the collection, or the point, the collective of the two answers that we got, 7, -10. So how do you classify that system, everybody? It was, what is that? I didn't hear that. Consistent, independent. Do we agree? All right, we agree. Have a great weekend.